Okay, only serious people are going to have faith. Okay, I think that we're headed for a time that the convenient Christians and the lazy Christians and the Christians that want to make their faith only superficial, I think they're going to drop by the wayside. And I think the reason for that is that Satan has way better ways to deceive people now than he ever did. Dale's been doing a wonderful job in of the spiritual battles and all those things. All right, it is not possible for us to just sit here and say, I don't want to deal with all those problems. It's too complicated for me. I just don't want to fight that battle. Well, if you don't fight that battle, we're going to lose. We're going to lose our souls. We're going to lose our kids. We're not going to influence the world for good. And one of the things, a couple of scary things, okay, that does not have to intimidate us. Okay, as Dale has said, we don't have to be intimidated because he who is what? He who is with us is greater than those. But, okay, Jesus himself said in Luke 18:6, or it says the Lord said, and of course in the New Testament, Lord always means who? It always means Jesus. It doesn't mean God, it means Jesus. In the Old Testament, capital L, little o, little r, little d, okay, means God, one aspect of God, and capital L, capital O, capital R, capital D means Yahweh, the I am. Okay, but in the New Testament, the Lord means Jesus. Jesus said, hear what the unrighteous judge said. Now will not God bring about justice for his elect who cry to him day and night? And will he delay long over them? He says, I tell you that he will bring about justice for them quickly. However, when the Son of Man comes, will he find faith on the earth? Now there's another passage similar to this where it says, as in the days of who? As in the days of Noah. Okay, all right, how bad were things in the days of Noah? All right, this question Jesus posed was real in that time, because God's in Genesis 6. All right, God says, I think I'm going to do away with him. I think I'm going to clean it off. Except he found a little bit of faith and he decided to, all right. And so, I really feel like we're coming at a time when the superficial things that Christians have squabbled about and split about and divided about, I think those are going to, lots of those are going to melt away. It's going to get down, to serious issues of faith. All right, that's why I think we have to have a rational faith. We have to have a rational faith because our faith, the case of the whole Bible is that our God is a real God who does real things and he makes sense. He is not erratic. He is not unpredictable. He is not random. And you don't have to be deluded or ignorant or gullible to have a strong faith, okay? And so that's why I think this is so important for all of us to at least be able, to articulate the sources, and the main, really the main concepts. Now, just so we don't run out of time either tonight or tomorrow night, I want you to, if you want, write down a few resources that I recommend to you, okay? By far and away, the best one I know of and have used all my life, and I've known this man, my mom and dad knew this guy, and he's traveled the United States for 50 years and never made a dime. He's a high school science teacher. He was raised an atheist till he was 22. He was in his dorm room when he was 22 with a gun between his knees and was going to blow his head off, coming to the conclusion that what? Life was meaningless. Okay? And a Christian girl, a Christian girl saved his life and set him on a search, an honest search for God. Well, that's Mr. Clayton's history. Okay, he has traveled on average, 35 weekends a year for 45 years doing free seminars across the country. The great thing about his work is he never fudges anything. He doesn't over-dramatize anything. If you ask him a question and there's not a good answer, he says, I don't know. He says, you can find people that'll tell you there's an answer to that. He's not. All his stuff is free. It's all online. We use these at school on all kinds of topics. One of the things that he covers that the little kids are doing tomorrow, which I've decided I'm not going to do, which is dinosaurs. Dinosaurs are cool. Everybody likes to talk about dinosaurs. Nobody really knows the answer to dinosaurs. They don't. And the Bible doesn't clear it up for us, and the science is not very good. There was a time when well-meaning Christians claimed what? That there never were any dinosaurs. It's all a complete hoax. There never were any dinosaurs. Well, that doesn't help God at all. Take your irrational. But I want to recommend this to you. He'll send it to you for free. If you want to pay the shipping, you can do that. But for your children, your grandchildren, for yourself, it's terrific. The other are the two things which our congregation has some connection with, and we're going to see about 5 minutes of one of them tonight, the privileged planet. And the other one, where does the evidence lead, which we're also going to see a clip from tonight. All right, these are state-of-the-art, honest, absolutely honest presentations about the rationale for a belief in God. And they are very powerful, and we are able to understand these things. We are. And we're able to see, that they make sense. Now, we ended yesterday, talking about teleology, which was the evidence for intelligent design. And we started in our daily life. Today I forgot to bring them, but I was going to bring a crescent wrench. Everybody know what a crescent wrench is? Its real name is an adjustable wrench. If you ever had FFA, it's called an adjustable wrench. Crescent is what the brand, But if I held up a crescent wrench, every intelligent person would recognize what about that object? Somebody built it. Somebody designed it. It did not just what? It did not just happen. It was not. Something as simple as that. And we did a little demonstrations to do that. And so, all right, we look at this chair. And the chair screams what? Intelligence. It does. Information. I love these chairs. There's some real new intelligence that came in with this stuff right here. We've sat on really bad chairs, but all right, nobody would say that happened by accident. Well, we spent a lot of time with that. When we ended up talking about the anthropic principle, when we looked at the odds of all the factors necessary for us to be able to live on this particular planet. And we made the point mathematically, when you combine odds, you don't add them. You do what? You multiply them. And so the odds of one event, maybe 1 in 10 might happen. When you start multiplying odds, it gets very, very complicated, and the numbers get so astronomical that no rational person says that it is likely for it to happen. Now, I want you to see just about 5 minutes worth where it's run down. Now, the difference between John Clayton's stuff is it's 1980s Atari graphics. It's old. And he's 75 now, and he's bald, and he's got a kind of big old stomach on him. He's happy, he's got a squeaky voice. He doesn't have any charisma, but boy, has he got the facts. Does he have the rationale? Does he have the information? All right, Illustra Media is just the opposite. It's top-notch, first-rate. It's accurate, and it's easy to look at. And so I want us to see just their explanation of this principle here, about all the things that had to be right for this to be a habitable planet. All right, now let me do. He's hoping I'm going to do this good because I'm because I'm his pupil here on this. I'm supposed to be getting video. You think it's gonna? Should I hit it again? Oh, I'm sorry. All right. Now you think I could just hit go?
For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this? Why is what we think about the universe, why would it correspond to the way things really are?
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
The spectacular progress of modern astronomy and physics is the product of a universe accessible to the human eye and mind. It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
If you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way. That is, you couldn't have galaxies, you couldn't have planets, you couldn't have complex biological organisms if these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate this concept, imagine a machine able to control the strengths of each of the physical constants. If you changed even slightly from its current setting the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it by a little bit, no large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. For example, the strengths of the other forces are all important, the masses of the various subatomic particles. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
These forces and constants are another example of the correlation between life and discovery. For not only are they finely tuned for our existence, they can also be understood.
It's remarkable how well the laws work, and not only that, it's remarkable how simple they are. And that also is related to the discoverability of the laws.
Albert Einstein wrote, I have deep faith that the principles of the universe will be both beautiful and simple. For nearly 400 years, scientists have discovered an elegant simplicity in the mathematical equations that express and unlock the laws of the cosmos.
It's been said that many of the most important theories in theoretical physics can be written on a single sheet of paper. And this, I think, ought to be considered surprising, that such a simple formula or equation could have such far-reaching applications to a very complicated and very large universe.
What you have is a universe that is not only finely tuned for life to occur, but also has a beautiful, elegant mathematical structure, and a structure such that we can discover that structure.
Most scientists just take it for granted that the world is both ordered and intelligible. And the intelligible part I find really quite extraordinary, because it's one thing to accept.
Okay, now did you see the two words he used there? What did he say? Ordered and intelligent, because it all functions off of information. It all functions off of information. Now, information, okay, has no importance in random events. Okay, now, okay, we're going to leave astronomy, okay, because even though it's, you know, pretty interesting and there's tremendous order there, okay, there's tremendous order there. Think about the fact that in 1961, in his inaugural address, Kennedy said what? We choose to go to the moon. You know, when he said that, he hadn't broken that to the scientists, to the people. He hadn't told anybody that. He gets up and throws it out there. When did we get there? 69. We got there in 69. All right, we did that totally different than what the Russians did, and they never did go. They never did go. They did beat us into space. How'd they do it? Why'd they beat us? They started sending people before what? Before it was safe. Before they figured it out. Okay, all right, we waited to send people because we knew if we took our time, we could what? We could figure it out. You can only figure out something that is what? That is intelligible and ordered. All right, what's the most difficult murder to solve? One that has no motive. Okay, when these kids go out on Friday night and do what they call random shootings, okay, it's because there wasn't any thought went into it. Anything that has been planned can be figured out. Okay, no code is unbreakable. Why? An intelligence did what? Created it. And if an intelligence created it, it can be what? It can be figured out. Now, what we want to go to tonight is an examination of, let's see if I can do this quickly. I want to get to a new, I think I'm going to do this. All right, don't forget what we've talked now about the mathematical odds, okay, the probabilities. This is going to be very, very important. Now, what we're going to look at is proteins. We're going to look at proteins. All right, this is going to affect itself. What do I need to do? All right, I need to change from projector. And I do this. It's going to give me a choice here in a second. I'm going to go down to computer, as it is. We're back on computer. And then I need to go to slideshow. Go to from the beginning. All right. Now, All right, the little kids are studying creation, okay, and I was supposed to sort of follow along with what they were doing, and I've done that sort of, okay? But, all right, things we're going to look at right now, all right, apply both to the problem of, okay, organic evolution, okay, which is the theory that all living things, okay, evolved over time from the first simple organism to something as complex as us. That's organic evolution. Now, we ended yesterday throwing out the idea we should not argue ever against the fact of evolution. Natural selection, okay, is the mechanism for evolution. All evolution means in its purest definition is, okay, a change in the gene pool, in the frequency of genes in a gene pool. Okay, that's all it means. Gene pools do not stay the same. All right, if you go to the Orient, I don't know if that's correct anymore, you're supposed to say Asia or say Orient or whatever, okay? If you go to the Orient, people that have lived there for centuries, okay, a Cambodian can recognize a Korean. And a Korean can spot a Japanese, and a Japanese can spot a Chinese. Why? Why do they look clearly different? All right, even though to us, we sometimes say what? They all look alike. They do not. Okay, do you remember that in the middle of the 19th century, we went to war with Japan? A very brief war over what? Do you remember? No, Japan had a closed society to the world. They wanted no new genes. Well, when we started trading across the Pacific, we would go by the Japanese coast, and once in a while we would have shipwrecks, and the guys would all swim ashore. And the Japanese did what? They killed all the men. Why? They didn't want their genes in their population. Okay? The Koreans felt the same way. Chinese, the Vietnamese. Okay, when you have a closed gene pool and you go way back, a closed gene pool, you have gene frequencies for certain traits. Okay, this notion that everybody in the world is the same is ridiculous. It's not scientifically accurate, anything else. Okay, there are some genes in a human genome that are not in this room tonight. Okay, most of them are here. Okay, how many of you know you have genetic diabetes in your family? Okay, some of you do, some of you don't. Okay, there are other traits. Okay, natural selection is a fact, it's not a theory. Okay, there were several people that put it forward at the same time as Wallace and Darwin. Okay, Darwin got all the credit and Wallace got none. But both of them looked around and they said, you know, there are way too many living things born. They can't all live. So who lives? All right, the fittest. The word fit doesn't necessarily mean strongest or smartest or fastest or biggest or littlest. It means what? Right, in a particular environment, certain genes help you live better than others. And if you live, you reproduce, and you give your genes to the next generation, and the same thing starts all over again. Now that's a fact. It goes on all the time. It's going on right here, right now, where we live. And therefore, the gene frequencies change. Okay? Now, all right, oddly enough, this is one of the things, or one of the consequences of sin. Adam and Eve's genes, what were their quality? What was the quality of Adam and Eve's genes? They were perfect. They didn't have any bad genes. All right, why is it that incest is not morally illegal, but it is illegal in this country? Within first generation, why is it illegal? All right, because in our gene pool, there are many recessive, harmful genes. You all learned in biology the big letter or the little letter. A little letter was for a recessive gene. Okay? If you get a gene for a harmful trait and it's recessive, but you get a big capital letter gene for a normal trait, how do you come out? You're normal. You're normal. But if you marry your sister and she has the same recessive gene and y'all have kids, 1/4 of them are going to be defective, half of them are going to be carriers, and the other are going to be pure and normal. All right, so we don't argue against natural selection. We don't argue that gene pools change. They do. How many has ever shown livestock? Pigs, sheep, goats, whatever. We showed pigs for about 25 years. When we started, the pigs that won were tall and skinny and long-legged. But in about 5 years, they didn't want tall, skinny ones anymore. They wanted short, dumpy, fat ones. And right now, they want double-muscled Arnold Schwarzenegger hogs. All right, within 4 years, we changed all those hogs. How did we do it? We went looking for the genes. We selected the genes we wanted, okay? And we got rid of the genes we didn't want. That's evolution, okay? That's a fact. It goes on all the time. Now, okay, it is a brilliant part of God's plan. The brilliant part of God's plan is that over time, as environments change, organisms can what? They can adapt. Now, we're going through a crisis right now of this in farming because 20-something years ago, okay, it was Monsanto, okay, invented a chemical called Roundup. We've all used it. A lot of us have. Roundup, okay, we thought would kill everything. Kill everything, kills it all. But somebody found out that a particular weed, you could spray it with Roundup and it didn't die. And somebody guessed what? Must be because of a gene.
Or adaptation.
Okay, all right, it must be a gene. Must be a gene that equips them. So now we have taken that gene and we've put it in corn, we've put it in cotton, we put everything. But guess what the little weeds had happened to them in the last 3 or 4 years? All right, we call it resistance. But if all of a sudden, okay, they've developed resistance, what has happened in that organism? There's been some more genetic change. Well, that goes on all the time. This is what evolution is. The fact of changing gene pools. Creationists should not fear or deny this fact. That's when we get laughed at. Because remember, we don't have to be afraid or deny or diminish real science. We don't have to. It doesn't help God. Now, so microevolution within species does occur. All right, now we do most of it, okay? And we can do it fast. We can do it fast. By mass selection, all that means is we go find the genes and the organisms we want, and we reproduce with those, and we multiply the gene, okay? So that somebody in North Africa 600-700 years ago said, we want dogs fast enough to catch antelope. So what'd they do? They started breeding the fastest to the fastest. And all the fast animals of Africa and North America, how are they built? What kind of chests they got? Big, deep chests. What kind of waist they got? Little skinny ones. What kind of glutes have they got? All right, what kind of length of bones have they got? Long ones, okay? And pretty soon they got what? All right, what dog did they come up with? Greyhounds. Greyhounds. And someone else said, we want a dog that can find any other animal in any situation by smell. So what'd they do? They started breeding for dogs that had big old loose jowls and big old nose and built low to the ground with great sense of smell, and they multiply the genes. So that takes place all the time, okay? Now, we've even learned to do it intentionally. Okay, the Japanese have a favorite fish. It's sacred to them. What is it? The koi. What we call a what? A goldfish. Well, when you collect things, all of you that collect things, what do you want to add to your collection? Something new. Something nobody else has got. Well, if you're going to collect rare goldfish, what's the only way you're going to get new ones? Brand new ones. You're going to have a mutation. You're going to have a mutation. Now, okay, mutations happen naturally. What's the number one cause of damaged genes? That's what a mutation is. It's damage. What's the number one cause? Radiation. What's the number two cause? Chemicals. Not all chemicals do the same thing. Both of those will cause genetic damage. Okay. About 60 years ago, the Japanese got a bright idea. They said, let's take a whole bunch of goldfish eggs and let's fertilize them with male milt from goldfish. We fertilize them, and then we're going to do what to them? We're going to radiate them. And they radiated millions of goldfish. Now, most mutations are what? Good or bad? Bad. And even most of the bad ones are lethal. What does that mean? They kill them. But guess what? Some of them are not. How many's ever seen one of the most prized goldfish, the celestial goldfish? You know where his eyes are? They're on the top of his head. His eyes are right on the top of his head. Okay? All right, they irradiated them, and they got some that had fins that were twice as long as their bodies. They have them that have growths on their face that they can't even see out. They're called lion heads. And every time they got one, they said, wow, this is so cool. Nobody's got one like this. Microevolution takes place and is a fact. But all right, what we really want to be specific about is macroevolution. That's just a term. Okay, more often it'll be described as organic evolution. Okay, which is the idea that every living thing came from some original, primitive, single-celled organism. That's totally different than all the species of dogs we have came from an original wolf. All right, that's easy to explain. All of those still have the same number of chromosomes. They are cross-fertile. Okay, same thing we do with horses, the Clydesdale to the Shetland, to the racehorse, to the quarter horse. They're all horses. They're all cross-fertile. But the gene pool is different. Classical Darwinism is the theory suggested by initial evidence and hypothesis. It suggests the evolution of all extinct and existing living organisms from an original single-cell life form. That's not a stupid idea. It didn't even come about by somebody who said, I want to undermine everybody's faith in God and destroy Genesis. Okay, that's not where that idea came from. He was a young man. He went and he studied birds. The famous one is all the finches. And he saw all these different finches on this isolated island, and they had a little bit different sized beaks and different sized feet and different diets and everything. And he said, you know, maybe all these birds came here at one time, and maybe there was only one kind of finch, and over all these years, they kind of adapted by natural selection, by mutations, and maybe that explains it. Okay, that's not a stupid idea. Okay, it's not. But then he extrapolated it to the idea, well, maybe all living things develop this way. This is a theory that's still held by some biologists. It is not a fact or a law because more and more contradictory evidence has posed serious problems for the theory. This in no way discredits either natural selection or microevolution. Okay? Now, mutations are abnormal changes, accidents in genes or in their replication during two processes. We all grow by a process called mitosis, all right? So a sperm cell from your dad entered an egg cell from your mom, and 23 chromosomes from dad and 23 chromosomes from mom got together. It's about 100,000 genes makes a person. Okay, there's 100,000 proteins that make you. Now, most of them you have in common, but some of them are different because your noses are different, your hair's a different color, your ears are different. Okay, but they're all in those categories. Now, in mitosis, you started as a fertilized egg with 46 chromosomes, and 20 minutes later, you were what? You were 2 eggs. And 20 minutes later, you were what? 4 cells. And 20 minutes later, you were what? 8, and 16, and 32, and 64, and 128, and it keeps going. Pretty soon, you're a little hollow ball. And then after a while, you turn into kind of a bean, and then you kind of, you grow that way. How do you grow? What puts you together? The information that's contained in what we're going to see in just a moment. Now, okay, mutations are not supposed to happen. We don't want them to happen because they're almost always harmful, but they do. What does the environment do then with most mutations? Keep them or kill them off? Kills them off. Kills them off. It purifies itself, okay? But if a really good one comes along, what does it do? It keeps it because that organism is more fit and more likely to survive. Now, okay, a mutation, okay, in a sex cell is different. Okay, it's much different. If I get a mutation right here from a strike of an X-ray from outer space, which is coming through here right now, it's coming up out of the ground from radon. We're getting blasted by it all the time. We're getting damaged genes all the time. But if it damages one of my skin cells, okay, it's not going to hurt my kids. Why? Because it's my cell. It's in me. Okay, it may give me cancer. That's what it usually is. Okay? But if you damage a reproductive cell, that cell can do what? It can pass it on. Okay? Now, all right, women are born with all the reproductive eggs they're going to have when they're born baby girls. They got about 50, 60,000, and maybe 400 or 500 are going to mature during their lifetime. All right, men, all of our reproductive cells are purged about every 6 weeks. But if you damage some of those and they become babies, what could happen? All right, then you're going to have a problem. So, most mutations are harmful or lethal. Beneficial mutations may be selected by the environment and natural selection. This results in microevolution. But down here, no organism can adapt itself. No organism can say, you know, we're not fast enough. You know, our rabbit population around here is too slow, and too many of them are getting caught by coyotes. And so we need to be faster. So we need some fast genes. It doesn't work that way. Okay? It takes place randomly by accident, by damage from the environment. All right, the whole idea of organic evolution says that what has happened is everybody in this room, okay, that is the most complicated organism on the planet, we are. All right, all of us got all of this information by a long series of beneficial accidents. Okay? Now the question is not, can there be a beneficial accident? There can be. There have been. The question is it logical, is it mathematically probable that 100,000 of those genes would all be formed perfectly to assemble proteins? Now we're going to look at some great graphics which will show this to you. Now back when I was in high school, it was only about 10 years after Watson and Crick first suggested the DNA molecule as the twisted helix. How many remember that from biology? Okay, the twisted helix, okay? All right, the information that builds protein is contained in a gene, and a gene is nothing more than a piece of DNA. Now, I want you to see, okay, in this tremendously accurate graphic, all right, exactly how complicated this is, and apply to it, okay, your logic. Does it make sense, okay, that 100,000 genes, okay, could develop this way and create an organism like ourselves? Now let me, I want to put this one in right quick. How do I find eject? Open. Is it doing anything? Here we go. I want to go. How do I get it? Oh, I got to go this way. Oh, that's the wrong thing. Here we go. Just a second. I'm going to get this. Maybe. Come on. I'm about to get it. Be patient. All right. No, too far. All right. Now this is going to make it graphic for you, so some of the words that I'm trying to get through you'll be able to see.
By the early 1960s, most scientists had ruled out the possibility that random chemical reactions in the primordial waters of the early Earth had once produced complex protein molecules and the first living cells. Yet despite the limitations of blind chance, origin of life researchers continued their efforts to find a natural process that could have generated the first life.
The problem of biological origins is, for a very long time, I would say, has been a real deep interest to me just because of the scale of the problem, the importance of it. Where did we come from? Why are we here? All that kind of question. Probed from the point of view of natural science.
During the late 1960s and throughout the 70s and early 80s, Dean Kenyon was one of the leading chemical evolutionary theorists in the world. And like others in his field, he was trying to explain how life on Earth began through a purely natural process.
In 1969, Kenyon co-authored the book Biochemical Predestination. In it, he presented an intriguing naturalistic explanation for the origin of complex protein molecules, the primary components of living cells. Kenyon wrote, "Life might have been biochemically predestined by the properties of attraction that exist between its chemical parts, particularly between amino acids in proteins."
At the time that biochemical predestination came out, I and my co-author were totally convinced that we had the scientific explanation for origins.
Kenyon proposed that the chemical properties of the amino acids caused them to be attracted to each other, forming the long chains that became the first proteins, the most important components in the living cell. And this meant that life was effectively inevitable, predestined by nothing more than chemistry.
Many scientists embraced Kenyon's ideas, and over the next 20 years, Biochemical Predestination became a best-selling text on the theory of chemical evolution. Yet 5 years after the book's publication, Kenyon quietly began to doubt the plausibility of his own theory.
It was during that whole period of time that my doubts about certain aspects of the evolutionary account became apparent. When coming into contact with a powerful counter-argument given to me by one of my students, and I could not refute that counter-argument.
Kenyon was challenged to explain how the first proteins could have been assembled without the help of genetic instructions. In living cells today, chains of amino acids are not formed directly by forces of attraction between their parts, the scenario Kenyon envisioned on the early Earth. Instead, another large molecule within the cell stores instructions for sequencing the amino acids in proteins. It is called DNA.
Initially, Kenyon believed that proteins could have formed directly from amino acids without any DNA assembly instructions. And that's why so many scientists were excited about his theory.
Now, we got to stop here for a second. It took me a long time trying to teach and explain this to all kinds of ages of people before it finally hit me how it would make sense. All right, what makes a word? Letters. How many letters have we got? We got 26 letters. All right, how many words can be made with 26 letters? An infinite number. How do you make a word? Now, how many words can I make with those letters? How many? We're not going to say them all. We can put an O in there. We can put an E. You can put an I. Now, suppose we go out here. We make it longer. What can we do now? We can put two E's, two O's. Anybody know what a shote is? It's a kind of a pig. All right, we could make a lot of those. All right, letters only make words if you do what? If you put them in the right order. Now, if you're going to make a protein for anything, suppose just like my hair is protein. And underneath my skin, there's a place where hair is built. It is built out of protein. But it's built of amino acids that have to be in exactly the right. All right, I'm just going to put some random letters on here. There's a J, there's a K. And if you want to color the hair, or hair the color I've got, you have to use what? You got to use the right ones. And if you use the wrong ones, what do you get? You get different kind of hair. You get hair that's curly, you get hair that's straight, you get hair that's fine, you get hair that's heavy, you get hair that's blonde, you get red, you get brown, you get black. It all depends on how you spell the protein, okay? Now, all right, you can compare this also to, how about if this was the password I'm just making a short one. You type that in, and that's the address, and you type it in, and this is the correct address, and you do this, what happens? Doesn't work. Bounces back. All right, the deeper we go into this now, what I want you to keep in mind is, of all 100,000 proteins that make us, they all have to be spelled right. Now, okay, the trouble is, they're not near that simple. A typical protein has 3,000 atoms in it. Some more, some less. Okay, made of about, they still argue how many amino acids are essential. Most people say you got to eat at least 15, 12 or 13 or 15, and your body can make some. Some people say you need all 24. These are things like lysine and isoleucine and, okay, lots of these things you've heard, okay? That's what builds a protein. Now, they have to be spelled right. If they're not spelled right, what happens to the organism? It's going to be affected some way or another. It could die, it could be crippled, it could have all kinds of damage. All right, how many of you have ever had to do a really long, complicated one of these, and you accidentally hit a period instead of a comma? Okay? And sometimes you do it 3 or 4 times in a row because your mind keeps making you do the same mistake. And you're infuriated by that. But it has to be perfect. It has to be precise. If it's spelled wrong, it doesn't work. Now, if you'll look on the cans of diet soda, there's a warning underneath the ingredients. It's a warning to who? People who have phenylketonuria. People who have phenylketonuria do not have a gene to get rid of certain types of ketones which are toxic. The rest of us are sitting here and we're producing these and we're not dying because we've got that gene, okay? Now, as we look at what these guys said, because this guy was a world-renowned guy, and he said, well, it all just sort of happens. It's almost like Santa Claus. We don't know how it happens, but the amino acids just all line up like they're supposed to. Is that logical? Is that intelligent? No, because we've said everywhere you find order, you find what? You find intelligence. Now let's see where he goes on from this now.
But the more he and others learned about the properties of amino acids and proteins, the more he began to doubt that proteins could self-assemble without DNA.
In DNA, Kenyon encountered a molecule with a property he could not explain through natural processes. For locked securely within its double helix structure is a wealth of information in the form of precisely sequenced chemicals that scientists represent with the letters A, C, T, and G for adenine, cytosine, thymine, and guanine. In a written language, information is communicated by a precise arrangement of letters. In the same way, the instructions necessary to assemble amino acids into proteins are conveyed by the sequences of chemicals arranged along the spine of the DNA. This chemical code has been called the language of life, and it is the most densely packed and elaborately detailed assembly of information in the known universe.
Like other scientists working on the origin of life, Kenyon relied.
Did you hear that? In there, all this is information. It's a code. Now, I've never done computer programming. Anybody here done computer programming? Okay. And they hire people that can type at what speeds to do this, Marvin? 150 words a minute? 200? Fast. And they've got to be fast, but they also have to be what? Accurate. Okay, they got to be accurate. How accurate? Yeah, perfect. So much so that I think now you have to have computers to do some of the work, right? To make it program itself. Is that accurate? Oh, helps. Okay. All right, as he went into this, what he found is in all of our cells are filled with a code. Okay? It is a code. Okay? And it's readable just like that and just like words, only it is put into every single living thing. Listen as he goes on.
He had two choices. Either he had to explain where these genetic assembly instructions came from, or he had to explain how proteins could have arisen directly from amino acids without DNA in the primordial oceans. And in the end, he realized he could do neither.
It's an enormous problem how you could get together in one tiny submicroscopic volume of the primitive ocean all of the hundreds of different molecular components you would need in order for a self-replicating cycle to be established. And so my doubts about whether amino acids could order themselves into meaningful biological sequences on their own without pre-existing genetic material being present just reached, I guess for me, the intellectual breaking point sometime near the end of the decade of the 70s.
As Kenyon reevaluated his theory, new biochemical discoveries further weakened his conviction that amino acids could have organized themselves into proteins.
The more I conducted my own studies, including a period of time at NASA Ames Research Center, the more it became apparent that there were multiple difficulties with the chemical evolution account. And further experimental work showed that amino acids do not have the ability to order themselves into any biologically meaningful sequences.
Faced with mounting difficulties in his own theory and a growing body of scientific data about the importance of DNA, Kenyon was forced to confront the absolute necessity of genetic information.
The more I thought about the enormous problem that all of us who worked on this field had neglected to address, the problem of the origin of genetic information itself, then I really had to reassess my whole position regarding origins.
For Dean Kenyon, a new question became the focus of his search for life's origin. What was the source of the biological information in DNA?
If one could get it.
Okay, now some of you may be CSI fans or NCSI fans. They can take a piece of my hair, okay, and they can do what? All right, they can read all of the information that made me. All the information that made me. And the reason I look quite a bit like Uncle John, but not exactly, but we both look a lot like Grandpa Harry, is what? We were built from some of the same information. And we passed that on, and that's the reason my son, people say, resembles me. Because he was made with some of the same information. Now, all right, that's the code. They can break down now, all right, your entire code that built you. Anybody done that yet with doing these ancestry.coms? Or has anybody tried that yet? I don't know anybody that's sent off a sample and found out what your genome looks like. My dad. Okay, and it's a developing science, but the only reason it works is because that is the source of the information, okay, that builds a human being. It's the plans. Okay, just like we go to a contractor and we ask for a bid on a building, what does he ask for? I got to see the plans. I got to see the specs. And then when the electrician shows up and the plumber shows up and the framer shows up and the roofer shows up, what do they want to see? They want to see the plans, okay? Well, all right, when you look at, we're running out of time here. He did. He did. And, oh, Okay, I don't know that. I do know. All right, I do know, and it's common knowledge, okay, all right, that men like him and women like him who are high in their fields, okay, when they make these kind of statements, they are done with being invited to speak at conferences. They don't get any more promotions. They don't get moved up in the universities. They are blackballed. They are silenced, okay, because someone's not interested in the actual truth. Now, I got mixed up just now as I was walking over there. What was I going to do? This is bad. Somebody help me. All right, what was I going to do?
You weren't in a hurry, you're going to be very stat, but you do what you're going to write.
I know. Anyway, all right, we're going to go on. It was. All right. I don't know. I was talking about what? Yeah. Yeah. Okay. All right. All right. Let's move on from that anyway, though. So what we're talking about now is humans. I got it now. I remember where I'm from. We're made of 100,000 genes, more or less. Okay, it builds everything. How many think go into a nose? Do you think there's a nose gene? No. There are dozens and dozens of nose genes. There's one for your right ear and there's one for your left ear. That's why what? That's the reason they go this way. Okay? If you got them switched, you'd have them pointed backwards, okay? All right, everything about you was planned, and there's a set of plans that built you. Now, here's the first bicycle. No, that maybe wasn't the first bicycle. Maybe this was the first bicycle. One of these really dangerous bicycles. Okay? Now, did the bicycle evolve? Okay? And then it went to this. And then it got a chain on it. And then it got gears. And all right, everything when it evolves gets what, generally? Simpler or more complex? All right, the first family station wagon was a what? It's a wagon with a horse. And then somebody said what? Let's figure out a way to eliminate the horse. And then how do we steer it? And it first started with a joystick, and then it went to a wheel, and then it got air conditioning, it got more complex. Well, okay, as you talk about, all right, the odds of this, all right, kind of development of plants happening by accident, okay, by mutation. This is an extremely complicated one. Now, let's take an amoeba. Most evolutionists say that the first living things, were single-celled organisms. As a cell, would a single-celled organism be more or less complex than a human cell? Now think about it carefully. Would a single-celled organism, an amoeba, be more or less complex than any single human body cell? It's got to be more complex. Why? All right, what does he have to do? Has to do everything. What does your red blood cell do? Primarily, what's the main thing it does? Carries oxygen. It's very simple. What does a white cell do? Okay, fights disease, does things like that. What does a muscle cell do? Just contracts. What does a nerve cell do? Carries messages. Most of our cells do what? One or two or three things. What does an amoeba have to do? Has to do everything. It has to reproduce. It has to respire. It has to grow. It has to do about 10 or 11 functions of a living thing. Well, to go from here to here, Huxley phrased it as, this happened by a long series of singularly beneficial accidents. All right, now can you get a good gene occasionally by a mutation? You can. You can. But they're rare and they're far apart. Most mutations are harmful. And so, okay, all right, if this is going to happen, if this is true, it absolutely demands a giant extended period of time. All right, I've done this experiment with my seniors in class. I bring in a 3-year-old, okay, and I sit them in front of a computer, and I ask them to start typing. And I ask the kids, what are the odds that this child will type a one-letter word? What are the odds? One-letter word. If he just sits there and just starts doing this, okay, is he going to? What about a 2-letter word? How about a 3-letter word? How about a 4, 5, 6, 7, 8-letter word? What about a sentence? What about a paragraph that makes sense? What about a chapter? Okay? All right, that would be random chance. Now, I tried doing it myself with a blindfold on, but that doesn't work very good. Why? All right, because I kind of know sort of where the keys are, and I have to intentionally move my hands around. Now, if somebody scrambled the board, it would work. All right. All right, as you look at evolution, okay, organic evolution, okay, it requires the logical mind to say that from the amoeba all the way through us, with all the hundreds of thousands of organisms, both still alive and extinct, every one of them had from 100,000 down to 20 or 30,000 singularly beneficial accidents that just programmed the proteins alone. Now, we don't have time to go to the next film. One of the things nobody answered is that when we eat our protein, and it goes into our stomach, what does our stomach immediately do to the protein? Rips it apart to its what? To its individual amino acids. And if you get cut right here, and you get gashed right here, and you need some protein, the blood sends what? The amino acids that you ate in breakfast and supper yesterday that are floating in your bloodstream, it sends them there and does what to them? Puts them together to rebuild what you need to fix the cut, which is muscle, which is skin. Now, when you look at this, of course, one of the big questions was, okay, they're all floating around in your cell, and the graphics that you ought to see if you order this one for your family, and you should have it. All right, we said, well, how do they get together? In other words, if you need a lysine with an isoleucine, all right, how do you get them together? Well, the people didn't want to face that, just said, well, it's just kind of magic. You know, they're just attracted to each other to get together. We know what they have found out now and they have seen. Okay, there are little machines in the cell that are themselves made of proteins, and these little machines go over, and when it needs a lysine, the information tells it to go find a lysine, it grabs it, and it swims with it back over and does what to it? It starts sticking them together, just like if I had a big box full of letters and I spelled anti-disestablishmentarianism for you or told you to spell it, what would you have to do? First, you'd have to know how to spell it. You'd go looking for A-N-T-I. But if you just thought about it, would you get the word? What do you have to have? You have to have somebody that does what? Goes and gets the A and puts it here, and gets the N and puts it here, and gets the T and puts it here, and strings them together and makes the word. Organic evolution claims that all of that happened by accident. Okay? And that is just absolutely preposterous. Okay? It is preposterous. Okay? It's not a question of can there be good mutations that might change a gene pool, that might change a population. The answer to that is yes. Answer to that is yes. There could be a gene, but that's not the question. The question is, what is the logic, okay, of all this information going together randomly by accident without purpose? Nothing else in our life, would we approach with that kind of logic. We would say that's crazy. It's crazy. All right, we said at the beginning, we live at the height of the age of reason. Okay, we are just about, well, actually, we're way past Tower of Babel. Okay, we've blown past them. You have to be very careful today to say what they can and can't do. Okay, what mankind can and can't do is going to be really small. But the way we do all that is with what? Intelligence and purpose and order and planning. And then to interpolate backwards that all of this happened by accident just makes no sense at all to a logical mind. All right, the more we learn, the more apparent that is. Okay, right? In the old days when we didn't know much, they used to believe that trees, the weight of a tree came from soil. They taught that. When we know most of the weight of a tree now comes from water and carbon dioxide from the air. The idea that this could have all happened by accident has been refuted by science. Okay? The only reason you hang on to it, is because you have some other motive. We'll close with this. What would be the motive? What would be a possible motive for some of the smartest people ever, to have taken the very same information which awes a God-fearer? What would be the motive why they would want to reject clear evidence? What? Job security, maybe so. Okay. All right, one is, in other words, if there is this ultimate force, God, who has a will for my life, and I don't want to recognize it, that's one reason. There's another reason that puts a burden on us. What is the track record of religion in the world? Good or bad? It's not good. It's not good. All the false religions, all the vicious things that have been done in the name of who? Jesus and God. Christians killing Christians for centuries, Christians being vicious and hateful to other people that aren't Christians. We have a big burden. I think, to present the truth about God in a Christian way. Okay, we have to live that. Otherwise, people are going to, turn us off immediately. Special creation, which is what the Bible claims. Special creation claims that God organized all of this. Okay, that God did it. Okay. All right, that itself requires a step of faith. Requires a step of faith. All right, what does this require to say that it happened by a random chance accident? Okay, it takes a rejection, okay, of plain logic. It does. Even though we can't explain every single part of this, it's kind of like someone said, you don't have to know how to play a violin when somebody's playing one badly. See? You don't have to understand everything about something to know that that doesn't make sense. And so, all right, was the idea that maybe everything evolved, was it a vicious, cruel, horrible, stupid idea? No. Okay, but the evidence doesn't support it. And we are on the high ground in that regard. Thank you all. We'll see you tomorrow night and we'll finish.